Okay, 1.1 Day 2. Still graphs and graphing utilities. Here we're going to interpret the information about a graphing utilities viewing table, rectangle, or table. We're going to use a graph to determine intercepts, and we're going to interpret information given by graphs. So graphing calculators or graphing software packages for computers are referred to as graphing utilities, are graphers. To graph an equation in x and y using a graphing utility, enter the equation and specify the size of the viewing rectangle. The size of the viewing rectangle sets minimum and maximum values for both the x-axis and the y-axis. The negative 10, 10, 1 by negative 10, 10, 1 viewing rectangle is called the standard viewing rectangle. So on here, you notice they have the negative 10, 10, 1 by negative 10, 10, 1. All right, what this is telling us is that the x minimum is negative 10, our x max is positive 10, and our x scale is by ones. The x scale is when you see those lines. So if I'm doing this, it means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it means each line represents a 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 10. Okay? And then here we have our, the by means now we're going to go to our y's. So this would be our y minimum. This is our y maximum. And this is our y scale. So it's saying we're going to go down to negative 10. We're going to go up to positive 10. And each one of these lines represents a 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have a graph here, and I'm trying to pick the viewing window that goes with it, it might say something like negative 8 to 8, 2 by negative 9, 9, 3. And so what that means is on my x-axis right here, that the far point over here would be a negative 8. This point here would have to be a positive 8. And each one has to be a 2. So 2, 4, 6, 8. There it is. Negative 2, negative 4, negative 6, negative 8. Then after the by is my y's. So it says my y min will have to be negative 9. My y max has to be positive 9. And each line represents a 3. So you got to make sure it works out. So 3, 6, 9. We're going up. 3, negative 3, negative 6, negative 9. It works going down. Okay, if they'd have picked any other scale, if they'd have said these were by ones, then when we tried to do it, we would see that it doesn't work, so that couldn't be an answer. All right, understanding the viewing rectangle. So what does this viewing rectangle mean? So it says we have negative 100, 100, 50, by negative 100, 100, 10. So this one here tells me that my x minimum is negative 100, my x max is positive 100, and my x scale is 50. This one tells me my y minimum is negative 100, my y maximum is positive 100, and my y scale is by tens. So the y-axis is going to count 10, 20, 30, 40, where the x-axis is going to be counting 50, 100. All right, intercepts. An x-intercept of a graph is a coordinate of a point where the graph intersects the x-axis. The y-coordinate corresponding to the x-intercept is always 0. So when you're trying to find an x-intercept, you're going to let y equal 0. And when you write your ordered pair, it's the x-intercept. So x is going to get the number, and we let y equal 0. A y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. The x-coordinate corresponding to a y-intercept is always 0. So for the y-intercept, you're going to let x equal 0. And when you write it as an ordered pair, y is going to get the number because it's the y-intercept, and x we're going to let equal 0. So example 2 here says let's identify these intercepts. Identify the x and y intercepts. So look at your x-axis, and there's your x-intercept. So for our x-intercept, it's the x-intercept, so x gets the number, it's a -3, and we let y equal 0. Then let's go find that y-intercept. So find your y-axis, there's that y-intercept, because it's the y-intercept. Y is going to get that number, and we let x equal 0. Alright, and then interpreting information given by the graphs. So it says divorce rates are considerably higher for couples who marry in their teens. The equation D equals 4n plus 5 models the percentage D of marriages that end in divorce after n years if the wife is under 18 at the time of marriage. Determine the percentage of marriages ending in divorce after 15 years when the wife is under 18 at the time of marriage. Alright, so they gave us an equation here. Let's make sure we identify what our variables are. So D is equal to 4n plus 5. What does D represent? Well, it says models the percentage D of marriages that end in divorce. So D is the percentage of marriages that end in divorce. What is N? N years if the wife is 18 at the time of marriage. So it's after how many years when the wife is under 18 at the time of marriage. So then we get to our problem here. It says determine the percentage. So that means we're looking for D. Marriages ending in divorce 15 years after 15 years when the wife is under 18 at the time of marriage. So this is telling us that N is equal to 15. So we're going to plug that in. 4 times 15 is 60, plus 5 is 65. So 65% of marriages will end in divorce after 15 years. I'm just writing the question right now. When the wife is under 18 at the time of marriage. Alright, and then they did have a graph here, so we could graph this. Different ways to do it. We could pick some ordered pairs and plug in. So we're going to try that. We're going to pick some x's, plug it in, and get our y's. Oops. So we're talking about our x was the number of years after they got married. So we can't have a negative number of years. So I don't need any negative x values. The percentage, D was the percentage, that's our y. We're not going to have negative percentage, so we don't need any negative y values. So we're really just kind of looking at this first quadrant here. So this is the years after marriage, and this is the divorce percentage. Alright, so we have the equation D is equal to 4n plus 5. So let's pick 0, 5, 10, we gotta have 15 because that's the one we just did, and 20. So plug in 0, 4 times 0 is 0, plus 5 is 5. 4 times 5 is 20, plus 5 is 25. 4 times 10 is 40, plus 5 is 45. 4 times 15 is 60, plus 5 is 65. And 4 times 20 is 80, plus 5 is 85. So on my x's, I'm going to let every 3 lines represent 5 years. Make sure your increments stay the same. If your increments are off on your axis, then your graph is going to be off. And let's see, I'm going to let every line represent 10 here. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay? And then let's plot our points. So we have 0, 5, 5, 25, 10 is 45, 15 is 65, and so you should notice they should be making a line because this was linear, and 20 is 85. Then connect your points. And put your arrow on there. All right, and that's the end of 1.1.